It is 5 p.m. I'm delighted to introduce our speaker of today in our lecture series on sustainability in computer science. It's Professor Andreas Uhl from the University of Salzburg, and I'm very much looking forward to the presentation of Andreas. I know a bit what I guess he will talk about, and it's really exciting to know how much CO2 emission we generate with our new kind of sort of meeting infrastructure using social media, teleconferencing system, and so on. At the same time, one can ask, but what do we save by not traveling? But you know, this will be, I guess, also part of this presentation. Thank you, Andreas, that you are with us, and it is your floor.
Thank you very much. So corresponding to the topic of this talk, I will switch off my video in order to save some CO2. So of course, but I'm still here and I'm talking. So I'm going to talk about carbon footprint of social media and other popular platforms, and I will be especially looking into the scientific literature, what it has to say, and we will see that current results are difficult to compare, and one can ask questions about the reliability of results that we see so far. In any case, it's very clear that social media can have a tremendous impact on carbon footprint of computer usage, and changing small setting can make a big difference. And among those small settings, as was already mentioned, is by switching off video. That's kind of a surprising fact that this really can contribute a lot. Okay. Before I go into the core of the talk, I will first try to be a bit systematic here and talk about some topics in sustainability. Namely, the first topic is to talk about footprints. So which type of footprints do we see, and which type of footprints are used to determine the sustainability of different type of systems. So the footprints that are seen typically to assess impact of what we do on the resources of our planet are, well, the most well-known is, of course, carbon footprint, which is also called greenhouse gas footprint, for example. But there is also water footprint, land footprint, and material footprint. And I will briefly discuss those different types of footprint before getting more involved into social media and internet usage. So that's a slide with a lot of text here. So carbon footprint, or also greenhouse gas footprint, is basically an indicator that tries to determine the amount of greenhouse gases emitted from some activity, product, company, country. So whatever we consider, whatever we look at, so we try to assess the total amount of greenhouse gases. And how is this reported? So carbon footprints are reported in tons of emissions, so CO2 equivalent emissions, typically per unit of comparison. And the unit of comparison is like per year or per person, per kilogram protein, per kilogram traveled, and things like that. So for a specific action or for a specific entity or whatever, we look at the tons of emissions in CO2 equivalent. If we look at a particular product, the carbon footprint looks at the emissions for the entire life cycle. This is very central. We will talk about this life cycle in a minute. So this life cycle means from the production of this product along the supply chain to consumption and also disposal. So really the entire lifespan is considered, and we look at the various consumptions that occur over this entire life cycle. And of course, if we look at climate change mitigation activities, this footprint, the carbon footprint, helps to distinguish economic activities with a high footprint from those with a low footprint, to see, okay, what is still okay to do and from which activities should we refrain from. When we talk about greenhouse gas footprints or CO2 equivalents, what does that mean? So for carbon footprint, some scientists really include only CO2, but it's more common to say, okay, we will include a list of the most important greenhouse gases, and they are kind of made comparable by using carbon dioxide equivalents over some relevant time scale, like 100 years. So the terms greenhouse gas footprint or climate footprints are sometimes used equivalently. And it means, okay, this is CO2 equivalent, even though other types of gases might still be important, but they're just converted, basically. Okay, some examples for carbon footprint. So you see here this nice illustration, which is sometimes used and illustrates what we all include here. So typically large contributors are, of course, energy stuff like fuel, gas, transport, travel, electricity, and so on, but also waste, recycling, and so on. If we look at the annual CO2 emissions, tons per person, in the year 2021, it's kind of interesting to look at it. So the top here in this list is Kuwait with 25. Well, it's mostly gas and oil that is used to produce energy there. But still, we have Australia and the US in a very poor condition here, so to say. Austria, having 7.2 tons per person, is comparable to China, and this is still, as of 2024, still the case. So we have a comparable emission balance, so to say, as China. So China is often regarded as the biggest polluter or CO2 emittent. Note that this is not the overall emission, but the emission per person. So China is heavily populated, so this helps. But when looking at the emission per person, we see that China is much better here off than the US, for example, or Australia. So interesting kind of to see that. So we are on par with this China and Germany, of course. France is lower, and we know that. So this is due to the large share of atomic energy that is produced in France, which helps in terms of carbon footprint. The discussion is ongoing if this is really desirable to reduce the carbon footprint in this way, but yeah, like it is done now, this is a fact. Okay, where is this come from? Are there standardizations? And yes, so the greenhouse gas protocol is nowadays a group of standards that are most common in greenhouse gas accounting. And those standards define accounting principles, relevance, completeness, consistency, transparency, and accuracy here. And these standards are published by ISO in the 14064 standard suite, was published in 2006. And these standards divide the emissions into 3 scopes. That's interesting. So that also shows that we have a wide scope to look at. Scope 1 covers all the direct emissions within a corporate boundary. So if we look at the company, for example, it includes, for example, fuel combustion of company vehicles, like emissions. Scope 2 covers the so-called indirect greenhouse gas emissions from consumption of purchased electricity, heat, cooling, or steam. And Scope 3 are the emission sources from suppliers and product users, also known as the so-called value chain. So transportation of goods and other indirect emissions are part of this scope. There is also a nice graphic here that shows this. So Scope 1, the green one in the middle, so that's the direct thing we always look at. But then we have this scope 2 and then scope 3. So if we use, of course, electricity or heat, then of course also these emissions do arise. And these are, so to say, the secondary in scope 2. And scope 3 is something that is often forgotten. So that includes all outsourced activity, basically, the processing of products, renting or leasing vehicles, waste management, and also business trips. So when assessing the overall footprint, we have to look at, so also according to the standard, we have to look at these three scopes and really cover all these three, which already shows that really coming up with an estimation of the footprint is not so easy, because we have to involve quite a broad scope of activities and things that are going on. So that already points to the fact, okay, that's not trivial to really reliably assess these footprints. Okay, water footprint is something comparable. So the water footprint of an individual, community, product, or business, like before, is an environmental indicator measuring the volume of fresh water needed to produce the goods and services demanded by society. Yes, we have three different types. We have the blue water footprint. That's really the what is commonly known here. So the volume of water that has been sourced from surface or groundwater resources like lakes, rivers, wetland, and is either evaporated or incorporated into some product, or also taken from one body of water and returned to another. And we have the green water footprint. That's the amount of water from precipitation that, after having been stored at the root zone of plants, so the soil here, that's green water, that is lost by evapotranspiration, so evaporation and transpiration, or incorporated by plants. So this is in farming mostly. And then we have the gray water footprint. That's the volume of water that is required to dilute pollutants. So coming from industry, from factory, or municipal wastewater. So dilution to such an extent that the quality of the water meets agreed water quality standards. So the more wastewater we have, the larger the gray water footprint will be, because we need this water virtually to dilute the pollutants till the water has good quality again. Then land and material footprint. So water footprint is commonly used also next to carbon footprint, but land and material footprint is not so often used. Land footprint is the real amount of land wherever in the world that is needed to produce some product, or used by an individual organization or by a nation. For example, if we look at the European Union, the land footprint is estimated to be 269 millions of hectares. So that's 43% more than the agricultural land available in the European Union. And 73% of this land footprint is due to the consumption of animal products. The rest goes to vegetable oils and plant-based products. So we see that meat consumption contributes an enormous share to the land footprint that is consumed here. And by switching to a vegetarian is of course good for this land footprint. The material footprint is a consumption-based indicator of resource use. So it shows the link between the beginning of a production chain, where we start typically with raw material extracted from the natural environment or coming from recycling, and the end where the product and service is consumed. So these are those four types of footprints that are typically considered. An extremely important term for assessing sustainability is life cycle assessment or life cycle analysis. So that's a method which is used to evaluate the environmental impact of a product through its entire life cycle, starting from the extraction, processing of raw materials manufacturing, distribution, use, recycling, and final disposal. And these different stages, they all contribute to the consumption and then the footprints. And all these stages have to be considered of course, when trying to assess the environmental impact of a product. So a life cycle analysis study involves a thorough inventory of energy and materials that are used for these carbon, water, land, material footprints, which is not so easy. And so this life cycle analysis assesses the cumulative potential environmental impacts. Again, there is standardization for that. So widely recognized procedures for these life cycle analysis are included in the ISO 14000 series of environmental management standards, as for ISO 14040 and 14044 standard suites. So I've included here two ways to illustrate that. So I think it's clear from what I just explained. But when we try to transfer this now to social media applications activities, so we see in social media activities, we see a considerable amount of devices being involved. And so an exact modeling of the entire product life cycle for routers, we have cables, data centers, end user devices is difficult. So if we look at social media, we cannot restrict the attention to our local devices only, but we have to look at all the involved devices. So, and if we do a life cycle analysis, we have to do the life cycle analysis for all the devices that are involved, starting from all the network devices that are involved, all the data centers, and the end user devices. So that's already shows the complexity of doing a proper analysis of these techniques. Okay, now let's approach the topic a bit closer. So looking at the footprints of internet usage, there is, and I always refer to the literature in the footnote, as you see. So there is a study looking not only into the carbon footprint, illustrates also the differences among countries. And we already in this visualization, we see that there is a big variability. So we have carbon, water, and land footprint here. So carbon in red, water green, and land footprint in green. We see the median being plotted and also the minimum and the maximum. And we see a tremendous variability across the world, which is caused by different environments and different technologies that are used in different countries. So that's the footprint always given in CO2 equivalents gigabyte here, so liters or square cents. And greenhouse emissions, and the variability is tremendous. So where does this come from? So why do we see this high variability? And this next slide here, so this graphic illustrates the deviation of the environmental footprints of a unit of electricity used for data processing and transmission. So recall here, we only look at the electricity here, so nothing else. So that's not a life cycle analysis. It just looks at the footprints of the electricity used for data processing and transmission, and we see extreme differences among countries. So we see countries which have a large water footprint, for example, like Brazil. Also, UK and Germany have a large water footprint here. Then we see some countries which have an unexpected low carbon footprint, like Brazil, but also some countries that have this high land footprint here, like Brazil, Germany, and the UK. And well, there are some reasons for that. So these footprints have been calculated based on each country's energy mix. And of course, For example, if you look at Germany, what is happening there? Why do they have this large land footprint here? This comes from brown coal mining. So this brown coal mining consumes an incredible space for doing that, and this has this huge impact on the land footprint. Brazil, on the other hand, has this high water footprint required also for cooling, but also for large hydro energy here. So that's a downside here in this footprint here. And we see some countries with this lower carbon footprint as expected. Again, we see France here being very well for all these three footprints. Again, this is caused by atomic energy. So this type of energy has a very positive impact here on this type of energy and on this footprint. But this has to be paid with some, of course, high uncalculable costs for final storage of atomic waste here. But it's interesting to note that the difference among different countries are tremendous. So it's difficult to come up with a general statement about footprints, especially when we look at the electricity, which is important for social media. Okay, and since we have a kind of a telco here, it's also interesting to look at the impact of changing application settings. So what can we achieve by changing just application settings? And here we have two examples. We have streaming in HD and streaming in SD, so high definition and single definition. And we have video conferencing with video on and video off. And we compare the three footprints, so carbon, water footprint, land footprint for these different options. And what you see is a tremendous reduction here. So if you change the resolution in streaming, for example, you get a reduction of kind of a factor 8 if you change from high definition to single definition. If you turn off the video, it's even more extreme. So with video off, there is almost negligible carbon footprint of video conferencing. So that makes a tremendous difference here. We also see impact on the water footprint and also on the land footprint here. And then if we look at the reduction in percentage, like in streaming, we reduced 86% when reducing the streaming resolution to SD. We reduced by 96% when turning the video off in video conferencing. So in terms of footprint reduction, it's clear what we need to do. In terms of user convenience, it's kind of problematic. So especially in video conferencing, video really makes a big difference. That's clear because video conferencing without video is just telephone. But that's important to see. Yeah. So it can make a big difference just by taking personal decisions. They say, okay, now I turn this off this time because it's not necessary that I'm seen by my colleagues. They all know how I look, for example. And in the example given below, this is quantified to some more extent here. Expressing this in the extent, the quantity of CO2 emissions here, and then comparing this with driving by car. So comparing the monthly footprint with a car ride from Baltimore to Philadelphia, for example. So this is taken from a US publication here. But also, for example, if 70 million streaming subscribers reduce from H2 to SD, we see a monthly reduction of 3.5 million tons of CO2 emissions, which is the equivalent of eliminating 1.7 million tons of coals, or 6% of the total monthly US coal use. So the impact can be tremendous, and this is kind of surprising. So you would not think that this can make such a big difference here, but it does. So it makes sense to consider this. Yeah, this again is a second comparison. So with turning off the video in the video conferencing. So this again compares the emissions of powering a town with coal, a town with 36,000 people. So that's also a lot that can be contributed here. Okay, so that's an important point to make. So apart from all the uncertainties that we will see subsequently, it is clear that we can achieve a lot. And the extent of achievements that can be done by simply reducing application settings and using sensible application settings are surprisingly high. Okay, so I'd like to talk not only about social media, so I will give a quick look into history. So the first topic I'll be talking about is the news. So what about news consumption? So in context of this is the impact of printing technology versus electronic versions of newspapers, basically. So comparing the consumption of a newspaper in printed form and then tablet-based e-paper reading is discussed here in this publication number 3. And comparing consumption of news via newspaper, online newspaper, and broadcast TV was done in this publication 4, and we will have a look into those results briefly. So this shows the system boundary that is considered in this work. So for the classical newspaper, so that's the circle on top, we have use, we have the transport, such that the newspaper comes to the client after production. And then we have again a transport such that the newspaper goes to disposal, and eventually in recycling, this goes back to production. If we have news delivered via TV set or computer, we also have some production, then the news and disposal, but without transportation. Transportation only over network, so to say. So either via networks or so different types of networks, basically. What we don't include is here is environmental costs of journalism and the recycling of electronic waste. So what is included here in the upper circle is paper recycling, but recycling of electronic waste is not considered in this work, which is of course the weakness here. Here in this work, the environmental impact is assessed in eco points. This is a variant to the footprints that we discussed before. So this emphasizes energy consumption and related air emissions. Some emissions to water and land are also evaluated. So this is kind of a variant, one could say. And overall, we have a highly complex system that has to be modeled. And if you look at this paper, it's interesting to see that the majority of the modeling of the different components is taken from various existing sources, like the lifetime and energy consumption of devices, the disposal, the recycling of newspapers, disposal of electronic waste, manufacturing newspaper, and so on. So a lot of things are basically imported from other publications, which makes it a bit difficult to assess if this is realistic. One can only hope that the authors did a good job in checking the results. And in this work, it's mainly user behavior when consuming use that is modeled in this work and further used in the modeling. Also, the length of typical news items is looked into. Okay, so that's the first results here. So looking at one news item, so comparing the eco points of the different settings. So news item on TV, news item in online newspaper, and news item in a cutted printed newspaper. So what you see here is that the eco points that are used here in the internet newspaper are largest. interestingly. But this is important to see. This is really a single news item that is used. So it's a very small share of the newspaper that is considered here. Yeah, and we have these variance bars here that take into account the variability of news item that we see, of course. So here in this, if we consider one news item, the winner is the newspaper, surprisingly. And then the news item in the internet newspaper is worst, and in between news item on television. If we look at the daily news, so an entire newspaper, the situation changes drastically. So on the right-hand side, we have, so it's a Swiss paper, the Zurich NZZ, where we see that, okay, this is now the largest consumer of eco-points, followed by a thin newspaper. Then in the middle, the internet newspaper, and daily news TV is the smallest column. So this is very different if we compare just a single item with the entire newspaper. But if we look at the entire newspaper, then the results are as being expected, of course, because here newspaper production and then transport here make a large share of the eco points that are consumed. Whereas here it's much more efficient, where actually the use, so the consumption consumes much more eco points. Of course, sitting there and reading the newspaper does not consume a lot. While here we have electricity being consumed. We can look at the details. So how are the different parts distributed among each other? On the left-hand side is the environmental impact for the production phase of the newspaper life cycle. So of course here paper production is the largest share, and then the printing process, but 78% goes into paper production here. Whereas on the right side is the use phase for reading an online newspaper, and at that time this study was done. So these were the different parts here. So data transfer via router, the operation of the network, and then the computer that did the display, basically. Also, the energy mix can make a big difference here. And here on the right-hand side, this is interesting because here the electricity mix was changed from the Swiss energy mix to the average European mix. And then the results get different. Because Switzerland has a very high share of hydro energy, whereas in the European mix at the time the situation was much worse. So here the relation among the different variants get really different. And especially the internet newspaper gets much worse here compared to the classical one. That changed in the meanwhile for certain, because if you think at the year when this study was done, this is almost 20 years back. So of course the costs of internet usage in terms of electricity will have gone down compared to the other parts. So this is not as pure. And the left graph shows the influence of the length of the time for the news consumption, where also, of course, it makes a difference if we have a longer news item or a shorter news item with respect to the eco points that are being consumed. True for the electronic media, which is not true, of course, for the synoptic newspaper, where we have this constant gray area. So, of course, the length is also something that matters here. Okay, second application case I would like to look into is streaming versus DVD. So in the 2010 years, we've seen an increase of streaming video entertainment, and this was a possibly less energy-intensive alternative to manufacturing and transporting digital video discs like DVDs and Blu-rays. And there is a study from 2014 that tries to do a life cycle assessment approach, estimating primary energy usage and greenhouse gas emission associated with video viewing, using both traditional DVD methods and online video streaming. Yeah, so this discussion is really prototype one. Yeah, so when looking at the dematerialization, so we have many application areas where physical goods have been replaced by digital ones. So this is kind of a prototypical investigation that has been done here. Streaming music and video entertainment are, of course, prominent examples here. Well, utilizing teleconferencing, we know this already, so reducing business travel and also online dating. So these are other examples where this dematerialization takes place and has to be considered concerning the footprint impact. Okay, so business models are considered here. So streaming video is typically assessed via DVD Blu-ray consumptions, and the following models are considered. So mail rented. It's like a Netflix model for mail service subscriptions where DVDs are mailed directly to the consumer from centralized warehouses. And this was interesting for me because I did not know that the origins of Netflix are in DVD mail service subscriptions. This is where this company comes from. And obviously, they changed their business model in the meanwhile. Okay, that's mail rented. Then we have store rented. Store rented DVDs. That means the consumer travels a short distance to pick up and return rental discs. So because it's rented, you pick them and you return them. Then you can have mail purchased. That's a variant of the mail rented, which means that you just buy the DVDs and they are sent to you directly, for example, via Amazon. And you can have store purchased if you buy a DVD and you look at it at home and you own it subsequently. Okay, this is the system diagram of DVD viewing analysis, which parts are involved, and this shows what is being considered in modeling the footprint here. So ranging from DVD manufacture to shipping to what is done in the warehouse, then what is done in delivery, so via personal vehicle or postal delivery, and playback by different media here, and then viewing with different monitors basically. And so these components and their so-called embodied CO2 emissions are included in the analysis. So this is for DVD video consumption, and for streaming video consumption, the same thing is done. So we look at the streaming source, so the data center, the building, the servers, the network, then the access network, cable, ADSL, the router, the cable box, then for playback, where do we play back this computer, game console, set-top box, laptop, smartphone, and then viewing flat screen TV. So this is considered in this comparison here, and this illustrate the results here. And what is interesting here, so we really have considerable differences here. So one thing, of course, is so then on the left-hand side we have streaming, and then streaming has a large share here of data transmission costs. So kind of the client devices are assumed to be pretty similar. The client device operation here is assumed to be lower here in streaming as compared to playing the DVD or Blu-ray on the device at home. What makes a big difference here is, and this is the major resulting impact here is the two cases of store rented and store purchased, and store rented being the worst option. And if we look at the reason for this is just this bar and this bar. And those two bars are just the transport of the DVD by the customer to the home, where if it's store rental business model, then you drive to the store, grab your stuff, drive back home, view the thing, drive back to the store, bring it back and drive back home. And if you purchase this, it's only half the effort. And this consumer transport, so this DVD transport by the consumer makes the big difference and make the store rented and store purchased the worst models here, whereas mail rented, mail purchased, and then streaming are at this time. It's always important to consider in which time this study has been done. So in 2014, or sorry, what was the time? Yeah, 2014. So data from these years have been taken, and here we have clearly the case that transport of the DVD by the customer makes a big difference. If this is transported by mail transport, that's not as bad, because for mail transport, other items are also transported, so this has not that strong impact on the carbon footprint as personal transport by the customer. When looking into this work in a bit more detail, there are some interesting details that some input parameters are surprisingly important for such things. So, for example, here, you wouldn't think about this, but the consumer travel distance is extremely important. But of course, if you consider that, it's very natural. So also the data transfer rate plays an important role here that we have. So that's the variability around the median that we have here. So there are many interesting aspects that contribute to these footprints that we look at. The vehicle fuel efficiency, of course, that's important because this transport of the DVD contributes a large share of the footprint. And if the vehicle fuel efficiency is good, then this pays off. So there are aspects that you would not think of usually when assessing these different types of consumption of video content. Okay, one thing I'd like to point out before really discussing social media is politics of ICT carbon footprint calculations. So because kind of that's a hot topic. So in 2020, electricity consumed by ICT was between 1.4 and 3.8% of global greenhouse gas emissions. So airline industry consumes 1.9%. So it's a large share. And about 1/3 of that can be attributed to streaming video, like video on demand platforms, YouTube, pornography, live streaming, and so on. This was in 2020. With the pandemic, this increased. So we saw an increase by 40%, and over 15% of the traffic was YouTube, 11% was Netflix. And even though these companies reduced their resolution to standard definition during that time, because the demand was so high. If we predict, then ICT will constitute 15% of global electricity consumption by 2040. So that's a significant share. So different stakeholders in this area, so in the ICT area, they follow very different political interests when it comes to studies with respect to ecologic footprints of different media types. So we must never forget that this is a highly political topic here. So it's very important to look at who are the authors, where are they affiliated actually. So it's difficult. So the carbon footprint of streaming media is difficult to tackle. There is work from 2022 where 22 ICT carbon footprint calculators and 9 calculators for streaming video have been surveyed and compared. So definition of the system boundary, so what is actually included in the analysis, is difficult and done in very different ways. And if done so differently, of course, the outcome is very different. Concerning data centers, networks, all devices, should the entire embodied energy, which means the energy involved in manufacture and disposal energy, should be included. So that's a significant issue, because in smartphone, we have 90% of electricity consumption is occurring before they reach the customers, so in production. The same is true, by the way, for cars. So if you talk about the footprint of cars, it's not mainly about the consumption while you drive. You have to look at the consumption in the production. So that's also tremendous. And here the story is slightly different between traditional cars and electric cars, by the way. Yeah, what about pollution in mining and disposal? Is this modeled? And there is a wide variety of methods for data collecting and system modeling. So as a consequence, that if we look into literature, trying to assess carbon footprint of streaming media, the disparity among result figures is enormous. And so we will see a lot of cherry picking. So looking at the most interesting results here when identifying data, modeling, resource consumption, and prediction here. So literature is sparse on the one hand, and what we have is not very reliable. And there is also politics more involved. So 2 citations here. We quickly realized that much of the literature on the subject used figures from previous documents, very often without cross-referencing them with others and without taking precautions regarding the limits of their validity. Second quote, as we researched more deeply, these issues turned out to reflect not only the regular turnover of scientific findings, but also ideological agendas. We began to identify alliances, rifts, and tribes among the engineers studying this topic. And as an example, I briefly go into this SHIFT project versus International Energy Agency case, which just illustrates this political issue here. So the SHIFT project has been developing an exhaustive calculator to assess carbon footprint of streaming media. So that's a French project, basically, and concludes that streaming video contributes about 1% of global greenhouse gas emissions. Those findings were, very, very well received, or not well received, but very well visible in popular media, were covered by BBC, The Guardian, New York Post, and so on. And this drew a rebuttal from a guy from the International Energy Agency. And this reply is, if you look into that, very interesting in tone and content here. And he did not simply criticize the findings and the techniques behind the findings. So he actually used all possible strategies to downplay the carbon footprint of ICT and to discredit the SHIFT project here in the eyes of a layperson who is not an expert in this field. And what's the unfair play that was done? So the International Energy Agency sets the focus on Netflix, which is unfair, because Netflix is unusually energy efficient. And also the content is hosted on content distribution networks near the end user, so this is misleading. Argumentation plays with artificial distinction of data centers and servers. So this minimizes energy usage of streaming for data centers. So this is kind of an artificial stuff here. And there was some confusion of megabits and megabytes in an interview by the SHIFT project. So it just multiplied all the figures by 8 and produced a chart that makes the findings of the SHIFT problems look ridiculous. So very unfair treatment here. So why is the International Energy Agency so keen to demolish this little French think tank here? So of course, yeah, the International Energy Agency wants to look like the footprint of network traffic. They want to downplay this. And this is when comparing their results to others. So these are CO2 emissions in kilogram associated with a half-hour show on Netflix in 2019. So this is the chart from the IEA. And you see here up there are the assessments by this guy. So very, very low CO2 emissions. And he compared that to the Shift project here, and this was the figure that was given. So on purpose exaggerated by a factor of 8 based on an interview that was given. In reality, this looks like here, so this is corrected. And then also when you look at other sources, this is kind of looks of very realistic what the Shift project does. So this, what the International Energy Agency did, is really a severe underestimation of the CO2 emissions that we see. Yeah, when comparing this to driving 5 kilometers, so when comparing this, so it's interesting comparison. So like a factor of 4 maybe is the consumption of an half-an-hour show on Netflix compared to driving 5 kilometers. So that's not nothing. So that's kind of a significant thing here that we see. Sorry, I did not want to jump already. But okay, now turning to social media, comparing the different types of social media. So it's important to see that the literature on this topic is really scarce. So that's not a lot we see here. So on the left-hand side, this is the comparison of social media generated CO2 emissions in 60 seconds versus on the right-hand side is the consumption within 1 hour. The right-hand side is a paper being published in MDPI sustainability, and it compares 4 different ways how to compute the footprint. So from the Shift project and from 3 publications that also dealt with the topic, and they considered YouTube, Netflix, and TikTok. And here, this green spectre is an open project that has been published, so without review, from 2021. And they found a different ranking here among the different sources. And at first sight, you could say, okay, looks reasonable. But if you look into detail, and we looked into the 3, the intersection of social media that are given here. So YouTube, Facebook, and TikTok is present in both studies. And if we see if we calculated hourly use now for all cases here, and we look at the green gas emissions, we see here, this is the range that is given from the 4 ways to determine that. We see that for YouTube, there's a big difference. So does not really fit. So it's underestimated. Facebook is overestimated by Green Spectre compared to these 4 methods here. And TikTok is on the lower range here. So what gets evident is that this assessment are non-consistent. So this is one of the few, so 2 of the few publications in the field, and the results are not really consistent here. So it seems to be pretty clear that there is no consistent methodology how to assess these footprints here for social media consumption. And if you look at these MDPI sustainability, by the way, that's in discussion if MDPI is a MDPI is a predatory publisher here. So the paper published there is very confused. In addition to that, the results do not seem extremely reliable. Yeah, so here is another example. So what's the carbon impact for a user of social media and mobile, to answer the question, so to say, of this presentation. So if you look at the social media consumption, the average on a mobile user per day is kind of equivalent to 1.5 kilometer travel by a light vehicle. If you look at what happens per year, it's 60 kilograms CO2, so equivalent of CO2 is equivalent of having 535 kilometers traveled by a light vehicle. So that's a considerable footprint that we have. So when comparing the CO2 footprints with driving a car. So that's, of course, not negligible. So you can compute your own social media footprint using this green spectrum methodology when using this link below. So the slides will be provided here. And here another example here where we see that bad examples do not really help here, in contrasting to that. So looking at the CO2 emissions for 1 hour and 1 day streaming here in one publication, and for 1 hour, what we see is okay. That's comparable. So a weighted average for different devices and different application is kind of equivalent to boiling a kettle. So okay, so hourly use, and then crazy stuff. They look at the daily use here and they compare it to a Paris-New York return flight. And for this flight, they assume something very low. So the return flight Paris-New York is of course much higher. It's 1,900 kilograms CO2 emissions, and very unclear what this small bar should represent here. So this suggests that, strange things. So of course, social media consumption cannot be compared to the footprint of an intercontinental flight. So that's ridiculous and does not help at all. Okay, so to conclude, there are some interesting observations when looking into literature in this field. So at first, it gets evident that literature is really scarce here. So there is not much there. And also, it's clear when you think about it, the modeling that has to be done requires an enormous background knowledge or trust in external resources. Still, if you trust the external resources, it's still very difficult and complicated. When looking into papers, you see that there are many shortcomings and mistakes. So there is really the demand for coming up with high quality publications in this field. So I think that would be something nice to do. One thing that is important to see, people and different organizations, they have a political, economical, ecological agenda. So this is not abstract knowledge and science. This is very, very political here. And the results often reveal surprisingly high ecological footprints for social media consumption, and also some very easy way to reduce those, like we said in the beginning. So I think we need here solid and reproducible research in this field to make it clear that social media consumption does have a significant ecological footprint, and even what we do individually can make a significant difference. So it's the same story. You can do something by yourself by reducing driving around with your car, but the same is true for how you work with ICT devices. Okay, thank you very much for your attention. So now I'll start the video again.
Thank you, Andreas. Yeah, it's I don't have to read thrillers anymore. I just listen to the different presentations. I really liked it. Thank you very much. There are some questions, but I think they have been answered. In fact, there was a thread of question on the slide with the DVD versus streaming results. I didn't get quite get why the client system share of the footprint is lower for streaming.
Yeah, there is simply the assumption that the device that is used for streaming is a different display. Like the older TV sets, they had a higher energy consumption compared to the flat screens we have now. And then so here we have this assumption in this study that for streaming, it's more the flat screens that are used, and for TV, the more traditional TV sets still have been used. So that's the underlying reason for that.
And as you said also in the second last slide, that there is some kind of dubious data and publications around. Do you know of any serious research in this area?
Well, these older papers I was referring to, so like this paper about modeling news consumption. I mean, as always, they need to import a lot of stuff, but how this study was done, I think this is a high quality work. And also this work with comparing DVD and streaming, which is already rather old, but still they also try to make a good point and try to model this as fair as possible. So these kind of older things, I think they have done reasonably well. For the newer stuff that I've shown now at the end. So the things that I found were really not good, but I did not find a lot. So it's really a lack of data that is seen.
Because I think it would be, in fact, in high demand to have here really serious research, especially to generate awareness. Not? As I was saying in the beginning, I always, when I in a Zoom meeting, I'm kind of remember your data, how much kind of energy produced in terms of coal. Coal is kind of used or can be saved. So, even, do you have any idea how to kind of kick off serious research in this area? Should the funding agencies kind of put forward a call, or even isn't this in our responsibility that we try to build up knowledge in this area?
Yeah, so maybe this could be one of the consequences of this lecture series. So people in Austria could contributing to this lecture series are obviously those who are kind of interested in this field. So we could sit together and brainstorm, thinking about maybe we could identify some funding lines or even talk to the ministry that we would like to do something in this direction. So there is lots of if you look at social media, 95% is on social impact. So and you hardly find these technically oriented paper that look into those more technical questions of social media. So it's all about, it's important, of course, yes, but this side is not seen, and then this might be true also for other areas where sustainability is an issue.
Yeah.
So maybe there would be room in Austria to start something in this direction, to do some better quality research as we see it now.
Yeah. So I look in the chat if there are any further questions. It seems, in fact, not. So because then I would like to thank again our speaker, Professor Andreas Uhl, for the very interesting presentation. There is one. Are data sets from the industrial sector in this line of work publicly available for research, or are you aware of companies would be required to publish such data sets in the near future? Okay, do you have an...
I cannot answer this. I don't know. I'm not aware of the availability of data.
Yeah.
That, of course, that's crucial, right? So if there is data available, then it's easier to analyze that compared to collecting your own data. But I'm a bit skeptical if this is really available or would be made available, especially if we have to reveal what we're going to use, we're going to do with the data. So maybe they would not be so interested in releasing that. So yeah, not sure.
There was also this question about when we compare DVD and streaming, shouldn't we also been talking about the rebound effect?
In the sense of what is meant by the rebound effect? I don't know if the person posing the question is still there. What is meant by the rebound effect?
Okay. But I'm just, to be honest, I'm just reading it also here now in parallel.
Yeah, I'm also seeing that.
That, when you say, I think I have a personal example now. I'm sometimes traveling with the bus from the south of Burgenland to Vienna. And since a year now, there is, it's a taxi collecting people, from rural areas, taking them to the next bus station, and then they can go, wherever they want to go. And I'm really happy about that, because when I'm there, most of the time when I'm alone there, I'm without car, so I can just call them and they bring me to the next bus station. But of course, by this I save energy, not driving my own car. But this taxi, which has normally, for 9 people, it's coming alone. So I go with a taxi with 9 people by 12 kilometers from my home to the next little city where the bus station is. So I guess this, of course, also costs energy. So there is, one would perhaps have to look at, not only what I am saving, but also what I am using and what the indirect costs of this usage are. Perhaps.
Okay, yeah. So it was just explained. If we reduce the emission of a technology, then people will using 10 times more. So the kind is
okay. This is
But I'm skeptical. So I think that the video consumption is not driven if you can stream it or not. So there were always people doing that, and of course, streaming it is easier. So a little bit of rebound, probably, yeah, because you just sit there and click. Yeah, it's an interesting question. Yeah. So yeah, I don't know, but this figure should be available. Like so this could be checked if the actual video consumption increased or was stable. Like, so I mean, a lot of shifted to streaming. Right? So the young generation does not watch TV anymore as we did or we do. So I'm still the traditional TV watcher, watching at the defined slides, and the young generation they stream almost everything, even if it's delayed for 15 minutes only, but it's streamed, so it's kind of better. Yeah, so it's an interesting question, yeah, to look at this. I cannot answer it, yeah. So it would be interesting to know the figures.
Okay. Since we have answered a lot of questions, I would like to thank our speaker again for the really very interesting presentation. Thank you to the audience for, being there and learning about, in fact, how to change the future for a better way. Thank you, Andreas. And we see each other next week. Next week, on the 4th of November, there will be the only hybrid lecture of this lecture series. There is an on-premise presentation of Sigrid Stagel from the University of Business. and economy on-premise at TU Wien, but of course it's also streamed for all the others in Austria. So everybody who is in Wien, in Vienna, you are invited to come in person, and all the others, of course, you can attend online. Andreas, thank you again, and see you next
Also,
time.
thanks for organizing this, Gerti. Thanks a lot.